Professor Gibney, he's an expert on human nutrition. He served on several EU and United Nations health committees and has been a professor at Trinity College and at UCD. That's interesting politics, both sides of the fence. He's currently the director of the UCD Institute of Food and Health. And actually one of his huge accomplishments, probably his biggest one, is his daughter, Sinead, who's here in Dublin. So just so we kind of declare the opal familial, and Sinead, who's actually driven the whole of our social engagement policy, which has been actually tremendous success. Also then to just declare my interest in the whole area of the food services business. I actually, if you all remember from Sandwichgate a couple of years ago, I serve on the board of Green Corps. So I'm obviously deeply interested in the area, and I've actually spent most of my evenings in the last week on board meetings dealing with stuff related to this. Mike's book is called Something to Chew On. If you get a chance to read it, you'll know he's some pretty controversial views. If you haven't, I think what you'll do is you'll hear during the course of the conversation those controversial views. I might encourage you to go out and actually get the book. And we probably have a couple of copies here as well. So first of all, Mike, let's see if you can convince us. Mike Gibney, welcome to Google.
Good afternoon, ladies and gentlemen. It's a pleasure to be here as part of Google Author scheme, and I'm here to talk about a book I've written, and I'm also going to mention a blog that I operate, Gibney on Food. I used to upload once a week, but I found it too much, so but the most recent one I uploaded was Dietary Supplements, Useless or Useful. That was this week. So I have about 35,000 hits and about 200, it's rising up to about 100 a day, 150 a day. And I wrote both of these because I'm sick and tired of rubbish I read in the media, sick and tired of people who are being confused by quasi-experts in the media, in the print media and in the electronic media. And very often when I give talks to the general public, I try to leave as much time as possible for questions. The reason being that people rarely get a chance to talk to someone who is, technically speaking, expert and neutral and willing to say it as it is. Quite often the people who write books are writing from a very narrow sensationalist and poor science-based point of view. So that's my take. So what I'm going to try and do today, just to say the book covers a wide variety of things, and I can't possibly cover them all. So what I've tried to do is make a list of 7 myths. And I'll go through these, and if time allows, I'll finish them all. And if it doesn't, I'll stop wherever I feel. But I'll try and go for about a half an hour. The first one I want to look at is whether or not obesity is a uniquely modern event. Now this, on the right-hand side of this screen, there's a book there called The End of Overeating, and it's by David Kessler, who was former head of the FDA in the United States. He's a pediatrician, or was a pediatrician. And he wrote this in his book. For thousands of years, human weight stayed remarkably constant. Throughout adulthood, we basically consume no more of the food we need to burn. People who were overweight stood apart from the general population. Please remember that now. They stood apart from the general population. Millions of calories passed through their bodies, yet with rare exceptions, our weight neither rose nor fell. Rare exceptions. And everything changed in the 1980s. Now, if Kessler is correct, then the solution to the problem of obesity will be around the 1980s. Something happened in the 1960s and 70s, or perhaps into the 80s and maybe 90s. But he's got a 40, 50, or even a 60-year period to look for the solution. But if he's wrong, as I'm going to show you, then he's going to make a mess of things. So I'll go back to Hippocrates. And he wrote in relation to the Scythian race about their children, and that the male children, until they were old enough to ride, most of their time were sitting in wagons, and they were talking very little since they were off changing their place of residence. And the girls get amazingly flabby and podgy. But that's not a rare event. And then one of the greatest writers of Roman time, Lucius Columella, he wrote that, the consequence is that ill health attends so slothful a manner of living, for the bodies of our young men are so flabby and enervated that death seems likely to make no change to them. And then you go to the city of Florence, the city-state of Florence. And this gentleman, Cornaro, wrote this book, still available on Amazon, by the way. He wrote it at the age of 94. And it's pretty important to read what he says. Gluttony kills every year as great a number as would perish during the time of the most dreadful pestilence, or by the sword, or the fire of many wars. A rare event? I don't think so. And then finally, I'll take you through to the 18th and 19th century to Sir William Wadd in London, who pointed out that the increase of wealth and refinement of modern times have tended to banish plague and pestilence. They have probably introduced the increased frequency of corpulence. For every one fat person in Spain or France, there are 100 in England. So that's still the case, I think. Apologies to my English colleagues. Now, this is a modern analysis. So it's interesting to look back in history, but we really need to do some science here. And this is a study which has looked at birth cohorts. Now, birth cohorts are very important because you take a group of people born in a certain period and you follow them throughout their lives. And then you take another group born 20 years later and you follow them through their lives. So you take a group in 1880, 1900, 1920, 40, 60, and follow them onwards. When you put it all together, you get a picture of the rate at which obesity has grown. And in this particular study, you'll see that from 1880 onwards to 1980, there has been a linear rise in the level of obesity. It isn't something that has happened at a flat rate and then suddenly appeared in 1980. And if you look at the rate of change, you'll see that it comes in waves. It starts, it slows, it rises again. I call this the tsunami of lard. Now, if you take a different approach to this is data from the US military, and they've looked at 4 periods, and I've taken the 45-year-olds military personnel there, and they showed an increase of 3.4 units of body mass index. And the increase was 7% for the first 30 years, 17% then for the next half century. The next one should read 17 years. Half of it took place in that 17 years after the war. And then again, it slowed down in the 1960s to 1990s to only a quarter of it. So again, you have this undulation and growth. It's best seen in some studies in Denmark, where they took children in the 1930s. They had 7, 8, 9, 10, 11-year-olds, and they followed them on a 6-monthly basis. And as you can see, there's a slow, gradual rise. And then in the 1940s, there's a spurt. And then it drops off again, and then there's another huge spurt. And then if you take the Danish military recruits, just started at the end of the Second World War, again you see the same pattern. A slow rise, a sudden rise, a dip, and then a very fast rise. So basically speaking, the authors of the paper I refer to, and there are many of them I could have shown you, but this was one I particularly like, they made 2 conclusions. Insofar as BMI values have been increasing gradually over a century, researchers attempting to understand the causes of the pandemic need to reflect or focus on the 1980s and thereafter to a much longer run process of social, technological, economic and cultural change. And then they go on to say that the finding also implies that the policy to attenuate or reverse the trend would have to reach deep into the social fabric and take into consideration that such socioeconomic forces generally change at glacial pace. So Kessler has it wrong in thinking that it all happened in the 1980s. And when he looks around for a solution, and he will identify sugar-sweetened beverages as one of the causes, he'll have gotten it wrong. And the problem with obesity is that I see there are 2 types of people take a scientific approach to obesity, the solutionists and the analysts. I'm an analyst. I like to find out why. The solutionists have an idea of what to do, and they justify doing it, such as taxing sugar. Now, this is the second myth, and it's about the stigma of obesity. I'll just go back and say that I'm going to introduce you to a number of impressions that most of you people in this room will have about obese people. Most of you will have these. If you're really truthful to yourself, you'll admit, yes, you have. First of all, you'll believe they're lazy. Then you'll believe that they're dishonest, that they're untidy, untrustworthy, unreliable, can't manage their time, have poor self-control, possibly low IQ, and low self-esteem. Now, that view is widely held by professionals who look after obese people. It's held by obese people, and sadly, it's held by obese children. The only thing that's true on that is the very last one, the self-esteem. The self-esteem doesn't happen because you were born with bad self-esteem. It happens because you got overweight or a little bit fat, and you experience all these prejudices, and your self-esteem suffers because of them. So if there's one thing I'd hope that would happen after this talk, the next time you see someone that's overweight, just be a little bit sympathetic. Just be a little bit sympathetic. So don't always imagine this. I'm going to show you a study that was repeated twice, and this was done with children. This shows you the scale of the problem. Boys were shown drawings of boys, and girls were shown drawings of girls, and there were 6 types. The first one was healthy, nothing wrong with them at all. The next one was disfigured face. The next one was on crutches with a brace on one leg. Then there was one with a wheelchair, one with no left hand, sorry, one in a wheelchair covered by a blanket, and one that was obese. And if the children were asked to rank them, who they'd like to be their friend most, and 5 was the one you didn't want to be friendly with. 1 was you wanted to be friends with them. And the results are staggering. Nobody wanted to be friends with the obese children. They'd rather be friends with people with all sorts of physical impairments, but not an obese child. Now, this is ingrained in children. It comes from their parents, and it's part of the way society thinks. So again, I say to you, the one thing I want you to do when you leave here is be a little bit considerate. Here are some people that are not lazy. They're not all of the things you think about them, and they're all fat and famous. Some of them are very rich and famous. Okay, the next one is the third myth is that obesity is uniquely caused by the environment and genes have nothing to do with it. And I was explaining last night when I was down in Cork that I gave a talk at a lecture once. I gave the opening talk to the World Congress of Public Health Nutrition. They asked me to pick 4 topics, any topic I like, hot topics. And I picked 4, one of which was genetics and obesity. And when I was finished talking, there was a queue at the microphone by eminent public health nutritionists, each vying to condemn me. How could I possibly say this? Genes have not changed for centuries. The environment has. Therefore, it has to be the environment, stupid. It can't be the genes. So I'll show you that's not true. These are 2 Maasai tribesmen from Kenya. They look after cattle, and they're nomadic. They walk long distances, so they've huge physical activity. They eat berries along the way. They drink the milk. Occasionally, they'll bleed the cattle and mix it with the milk and drink that. They live in a non-obesogenic environment. It's impossible to get fat as a Maasai warrior. Impossible. You spend so much energy walking around after your cattle and eating so sparsely that obesity just ain't possible. This is a food emporium in some shopping mall or other. You'll be familiar with them in airports and what have you. And this is an obesogenic environment. This is cheap food. This is tasty food. This is abundant food. It's immediate food. It's every cuisine food you like. And this is an obesogenic environment. Now, if I was to take 1,000 Kenyan tribesmen and bring them into this obesogenic environment, what would happen? Well, I would predict some would get fat very fast. I would predict some would get fat, but very slowly. Some would get overweight very fast, and some would get overweight very slowly. Some wouldn't gain weight at all. That is the difference. The difference in those people is due to genes. You put them in the same obesogenic environment. How they respond to that environment is genetically determined. So we live in an obesogenic environment. Those of us that gain weight are gaining weight because they have a genetic predisposition to do so in an obesogenic environment. Take away the environment, the genes don't matter. Put the environment there, the genes tell you who's going to get top of the league, middle of the league, or bottom of the league. So genes matter. So I'll show you some data on this. This is an old study carried out in the 1970s and forgotten because it didn't suit public health nutrition. It involved overfeeding twins, identical twins, and it also involved underfeeding identical twins, all carried out in clinical conditions, in other words, in a ward where they were supervised. So if I take some examples here, let's take the overfeeding one, and we have a green circle here. That dot represents 2 twins, 2 identical twins. If you go down the line to the change in body weight for twin B, it's around about 11 kilos. And if you go across to the weight gain on twin A, it's about 13 kilos. So they've gained more or less the same weight. Whereas if you go down to the red one, they resisted weight gain. Those two twins resisted weight gain more or less to within a kilo of one another. And then if you go on to the period where where 1,000 calories were taken away from them every day, they lost weight. But look at the ones in green. They lost very little. They resisted. Both twins resisted. In red, both twins showed a huge weight loss. So again, you can see that the genetic component is determining who responds to the environment, the obesogenic or the non-obesogenic environment. Now, the criticism of all of that was that it was carried out in the 1970s when we didn't really have the highly obesogenic environment we have today. So this lady, Jane Wardle at the University of London, has done some incredibly good work with twins, identical and non-identical. And the thing about identical and non-identical twins is they have a mathematical model which allows you to work out what part of the trait is heritable. So in the case of obesity, BMI, or body mass index, or waist circumference, 3/4, roughly speaking, is accountable for by genetic variation. That was exactly what they found in the 1970s as well. And about, you could say, of the remainder, a little bit more than half was in the non-shared environment of the children. So one child going off to play hockey, another going to go swimming, another going to drama, another going to do something else. And the shared environment was the home. Now, just to take this a little bit further, this is a longitudinal study of 428 twins. And they were from 100 obese families and 100 non-obese. Now, the obese, both parents had to be obese or both parents had to be slim. And they were followed from 4 to 11, which is a 7-year follow-up. And they had an 81% retention, which is very, very good. And this is obesity at age 4 and age 11. The gray bar represents the children of slim parents. And there was no change in the rate of obesity in those children between the age of 4 and 11. The black bar represents children both whose parents were obese. And you can see that there was a dramatic rise. Even by age 4, there was far more obesity in those that had obese parents. And by age 11, it was through the roof. Now, of course, you might argue that that's due to the home environment. But what I've shown you is that when you study twins, identical and non-identical twins, and you're able to take away the effect of the home environment, it comes out at less than, the environment comes out at less than 25%. The genes accounting for 25%, 75%. Now, I just want to bring in social class, because this is also another myth, so to speak. On the bottom, you see that we've broken this up now into 2 groups. Now, we still have the children who are born of lean parents, and over the period, the 7-year period, they showed no weight gain. Now we've divided them into 2 colors, blue and sort of red, and they're different social classes. And social class makes absolutely and utterly no difference if you happen to have 2 parents that are slim. But if you go to the top of this, where we had the children whose parents were overweight, then you see that social class becomes important. So what you have here is the same environment, but if you had the genes to keep you slim, you'll be slim in that environment. If you have the genes that make you fat, you'll get fat in that environment. And that is the reality of it. Once again, I say, take away the environment and you take away the problem. There's nothing to do with genes. But if anyone thinks they can turn this city into a non-obesogenic environment in a decade, you're a better man than I, Gunga Din. Just to add to what I've been saying, this is a recently published study of a huge number, 12,000 twin pairs from birth to 19 years of age. And basically speaking, the black line represents the inherited component of obesity, and the bottom line represents the environmental side. At birth, the environmental side or the genetic side is quite small, but by 6 months it's dominant. It drops at 4 or 5 years of age. I don't know why that is. Maybe it's going to school. It drops again at 7. I don't know why. But right throughout adolescence, it's the dominant determinant of weight in an obese environment. Once again, we have an obese environment. We have winners that win the top of the league, the bottom of the league, and the middle of the league. And that's determined by genetics. Your position on the league table is determined by genetics in an obesogenic environment. Now, many people think that if you're talking about the genetic control of obesity, you're talking about metabolic parameters. You're talking about how muscle, liver, adipose tissue behave. But in fact, in man, we have such a complicated system of selecting food, unlike rats, because we've got a big cortex and we can like things and dislike things. It's quite likely that the genetic variation applies to behavior as much as it does to metabolism. So Jane Wardle did this study of nearly 4,000 or 5,000 twin pairs, and she was looking at neophobia, whether children like new foods or don't like new foods. And what she found that 78% of the variability was genetic. Now this is beginning to open up an explanation of why is genetics important? Well, it's only important if it influences something that influences obesity. She's shown now that neophobia is strongly inherited and not necessarily taught. So we're making progress in that direction. Okay, moving away from obesity to things to do with the food chain. Everything that's synthetic is considered by people your age, roughly speaking, as being bad for us, and everything that's natural is considered very good for us. So let's take a look at that. There was this chap by the name of, he was Swiss, Philippus Theophrastus Aurelius Bombastus von Hohenheim. And even if I had his name, I'd change it. But he changed it to Paracelsus, which is equal to or greater than Celsus, who was a Roman physician and at the turn of the millennium, and quite a famous person. So Paracelsus gave us this one statement: all subjects are poisons, and nothing is without poison. Only the dose permits something not to be poisonous. Swiss alpine air injected into your veins will kill you. Pure Kerry water taken wrongly will kill you. Everything is toxic. Only the dose and the circumstances make the difference. So the dose alone makes the poison. And if you look at the human food chain, we have food divided into nutrients and non-nutrients. Nutrients are either added or they're natural. If they're added, they can be intentionally added, or they can be contaminants. And the naturals are what we call phytochemicals. And I want to talk about the phytochemicals now. Now, basically speaking, plants have a lot of colors and things like that, and smells and tastes for their benefit, not for ours. So the fact that the coffee bean is nice for us is nothing to do with the coffee bean. The coffee bean is designed for the coffee bean's purposes. They're not that philanthropic. So this is a bird now pollinating a flower, attracted to it by a scent, and then the bees are humming around the other one. There's nothing on the third flower because it's quite toxic, and the birds and bees don't go near it. It does its own cross-fertilization. And then you have on the bottom left 2 little shoots appearing. Did you ever wonder how a seed knows when it's springtime? How does it know that it's springtime? It detects temperature. So there are compounds in the seed designed for the seed to detect temperature. They detect water also. And when there's enough water and the temperature is right, they can germinate. But how do they know which way to go? Could they make a mistake and go down the way? You could easily. So they have oxygen centers, which tell them where the greatest gradient of oxygen is. So they have all these molecules in them, helping them to solve problems, including the seedling. Now, I put the rabbit there because plants can't run away from you. Plants have to stay there. So simple things, they sting you, or they have thorns. But in addition to that, they have many, many nasty chemicals in them, which the birds and the bees and the sheep and the dogs have learned not to touch because they're poisonous. And so the final reason why plants have these beautiful colors and so forth is that we can go to the toilet and get rid of metabolites we don't want. They can't. They have to accumulate them. They just save them up. And so we eat them, and that's what makes plants so lovely. The color, the taste, the smell, the texture, the aroma, all come from these compounds that the plant has to make its life easy. The fact that we find it tasty or good to look at is nothing to do with us. It's the plant is doing it for its own benefit. Now, if you look at these phytochemicals, these are 3 illegal and poisonous activities from phytochemicals. And these are 3 which are legal, but they're bioactive. So that tobacco is bioactive, coffee is bioactive, and this is a famous painting of an onion peeler. As instantly when it cuts into the onions. So plants have compounds in them that do things to us. And the best example I can give you is this Bulgarian dissident, George Markov. Any Bulgarians here? Remember this? No? Okay, he was a dissident, you see. He was living in London, and he was murdered with an umbrella. The umbrella had a secret tip on it from the Bulgarian Secret Service, and it contained a compound called ricin, which is derived from castor beans. And that's how they managed to kill him. The photograph you see on the top right-hand side is a group of British police raiding an Al-Qaeda factory where they were extracting ricin from castor beans. That led to all sorts of great jokes about ricin beans. Now, the point is that, of course, castor beans, like all beans, soaked for 20 minutes, it all goes away. You don't have a problem. But the point is, if I wanted to put ricin into burgers, let alone horse meat into burgers, I wouldn't be allowed, because ricin is quite dangerous. But Mother Nature doesn't have to answer to anybody. Mother Nature doesn't have to do it. So the last one I'll show you here is quite important. This is the University of California at Berkeley. They have 590 chemicals, of which 139 are natural and 451 are synthetic. And they use a thing called a rat carcinogen model. Now, in this model, you get as much of the chemical into the rat as you can. And you let the rat live until it dies of old age. And then you try to see, are there any cancers around? Now, it's not very pleasant and it's not very nice. But it saves lives because we don't have to be experimented on. But basically speaking, what they find here, of the natural compounds, 50% do produce some sort of cancer at some stage or other in these rats. And 61% of synthetic do, or 60% of synthetic do. No difference between them. So there's no inherent reason why something that's synthetic is bad, particularly given that we regulate it. And there's no inherent reason why something that's natural is good. Because if you really like it, I can give you a bowl of hemlock after this dinner, or inject you with some botulism, both of which are perfectly natural, and you won't see the afternoon out, don't worry. So natural is not necessarily the best. Now I come to organic farming. The argument is that organic agriculture produces safer, more nutritious, and more environmentally friendly foods. And basically speaking, they say they don't use pesticides. They say, wait a minute. You cannot grow crops, even in your back garden, without using something to control weeds and pests. Everyone who grows cabbage or lettuce knows that. The slugs will have it if you don't watch it. So they use it. They say, oh yes, but ours are natural and organic and so forth. So there's a growing interest in examining pesticides from a holistic environmental point of view, looking at a wide variety of things. And at the bottom part of this slide, the things that are important are dermal toxicity, toxicity to bees, fish, and birds, runoff into the soil and leaching potential, the residue that remains in the soil, and the half-life of the surface of the plant. And basically speaking, what you have here are two conventionals that score over 30, and then you've got four novels. Two of them are synthetic, and they range between 8 and 34, and two are organic, and they range between 17 and 30. So if you are going to take something that's going to kill a slug or kill a plant, remember it's a biocide, not sort of water. It's designed to kill. So don't expect it to be, way down the grade here. It's going to have effects on birds and bees because that's what it's supposed to do. Now, we look at the environmental impact, and it's argued that the organic agriculture is much more friendly to the environment. And in fact, when the British government commissioned this study, the conclusion was as follows. There's no clear-cut answer to the question which trolley has a lower environmental impact, the organic one or the conventional one. And let me just explain that. In order to grow plants, you need nitrogen. And a conventional farmer will use chemical nitrogen from a plant. In this case, there's two options. One is to grow a cover crop. Now, a cover crop is of a species of plant that actually extracts nitrogen from the air. Clover does it. It fixes nitrogen from the atmosphere. And then when it's fully grown, you plow it into the field. But what that means is 50% of your land is not used when you're doing this. So that's inefficient. That's not contributing to the environment. You then have to plow it in. Plowing is one of the most environmentally disastrous things on the farm. On the other hand, you can say, well, we won't do that. We'll just use manure. Where do you get the manure? From the dairy farmer. Thank you. You've got to buy some of his carbon footprint now because you're taking his manure. So when you look at the complexity of organic farming, it's not so straightforward at all. And then finally, when it comes down to nutrition, there's been many, many reviews. This is from the University of London. And basically their conclusion is that there's no evidence to support the selection of organically produced foodstuffs to increase the intake of specific nutrients or nutritionally relevant substances. Basically speaking, a carrot is a carrot. It has the DNA to make it a carrot. It can't decide halfway through, oh, I think I'll have a little bit more protein, or I think I'll do something else. It's hardwired to be a carrot, and it can do nothing else. So it doesn't matter what you put in the soil. You can stop it growing by not putting enough in. But if you put organic in or inorganic in, it will absorb the ions, and it will never know the difference. I haven't got time to go into the cooking side of things, so I'm going to leave that one out. Now, I don't think I'll have time to go into genetically modified foods in detail here, but this is a very emotive subject. And basically speaking, there is what I call the agromantic side of plant breeding, where it's all very lovely and going out and, you know, mixing with the birds and bees and so forth. But this is worth reading because this guy won the Nobel Prize for this. He was working with Drosophila, or moths. Basically speaking, he used X-ray irradiation to zap the flies. And what it does is rattle their genome to bits. And then it all falls back together again, causing mutations. And he was able to speed up breeding of these flies by tens of years because he could play around with the genome in a way that you couldn't do it. So that was extended to plants then. And basically speaking, although this is in Japan, it's no longer used because there are much smaller versions of it now. But basically speaking, what happens is the plant is hit with atomic radiation. And it goes something like this. The radiation hits the genome of the plant. There's the healthy plants in a circle around the genome. And then the genome is wrecked. And the vast majority of plants are useless. But the one in the circle has some trait that's good. And they backtrack that, they backbreed that with the original plant and hope to achieve something. And this is promoted by the United Nations. Just speed through this. Examples, all the rice you eat in the United States is grown by atomic irradiation. All the grapefruit you eat in the United States is grown by the radiation. All the whiskey you drink in Scotland and Ireland comes from barley that was mutated. And the figure is about 200,000 varieties have been released by the United Nations using this technology. Now, if you compare that to GM technology, it is cut and paste. So here you have, in the blue, you've got a gene. You've got an enzyme that splices the precise gene you want. It then goes over to the red gene and takes out, the enzyme takes a part of that out, puts the gene in, and another enzyme stitches it up again. Highly, highly precision. And if you make a comparison between trying to get the same trait in a plant using atomic radiation versus genetic engineering, you find that you have about 30 genes with changed expression in genetically engineering compared to 1,000 genes changed in the atomic mutation. You can sell the atomic mutated plants at your leisure. No rules, no regulations, no nothing. You cannot sell atomic or the GM crops. Basically speaking, coming to the end of my talk now, just to say that there are two types of resistant crops, so that the herbicide doesn't damage the crop. Both of them are have the resistant gene inserted. One is done by GM, one is done by mutation. One is very tightly regulated, and the other is not regulated at all. And basically speaking, in my view, if you're going to regulate genetically modified foods, as we do, then you must regulate all of the atomically or chemically mutated foods, as we don't, but we should. In my view, neither of them need the attention they're getting at the moment. And I think that the day will come when consumers will find that it's not nearly as bad as it's believed to be. Now, this is basically the last part where I talk locally grown food is favored for environmental reasons. Here's two apples. The first one is grown in Ireland, harvested 10 months ago. It's on the shelf. And right beside it is the one grown in New Zealand 10 days ago, and it's on the shelf. The one came from New Zealand on a ship, and the one came from Ireland was kept in pristine condition, controlling temperature, atmosphere, and various other devices to keep it fresh. Which one has the biggest carbon footprint? The one from Ireland, of course. So miles have nothing to do with carbon footprints. Absolutely nothing to do. Basically speaking, here's Irish tomatoes grown in a greenhouse. That's the only way we can grow them. They're Spanish tomatoes grown in the sunshine. Those are going to have the best carbon footprint. Okay, we have to import them, so they've got miles associated with them. Their environmental impact is much less. This is just to show you that when people talk about local food, and we should go for local food, it's fine for individuals to do it. It's fine for restaurants to do it. It's not possible for big cities to do it. And basically speaking, it's wrong to think that you can grow everything everywhere. This is a plot of where soybeans and wheat are grown in the United States. And you can see soybeans are all on the east, mid to the east coast. That's because the soil and climate favors it. Nobody on the west of the United States grows soybeans because it just doesn't suit them. On the other hand, if you look at wheat, you'll see that it's tending to go from the Midwest right across to the west. And nothing on the east because the soil doesn't suit it. And if you look at wheat itself, and you look at different types of wheat, you'll find that it's grown in different parts of the United States. And this is the second last slide I'll show you. If, for example, this city was to decide, we're going to get all our vegetable oil from locally grown rapeseed oil, we would need the entire County Louth just to provide Dublin with that oil. I don't know what Cork, Limerick, Waterford, and others in Belfast would do, but basically we've got Louth, thank you very much. What we do for the rest of our foods, I don't know. But it's very easy for individuals to go after local food. It would be impossible for a city like the size of Dublin or even Mexico, to take a really big city, or Beijing, impossible for them to think about local food. You are going to require a huge food chain. You are going to require trade and export. And finally, this little fellow was born yesterday, exactly 24 hours ago, so he's our new grandson. So, thank you. Thank you very much. I'm very happy to answer questions if there's any. I know you've got to go back to work as well, by the way. The boss is here. So.
First of all, thanks very much, Dad, for the talk. I know that some people were having difficulty seeing the slides, so I'll make sure that they're available to everyone after. We are recording this for YouTube, so if you do have any questions, just put your hand up and I'll bring you the mic.
Hello. Thank you for the presentation so far. I've got the question that recently was subject to a discussion between me and a few other people. Is it good or bad or acceptable or neutral to eat meat every day?
Well, it's acceptable. You can get away with it. It's not a problem. A lot of people don't like fish. My view would be that you should be able to have a little bit of variety. So I would be going for poultry, and I would be looking for a little bit of fish once a week or twice a week, and maybe some dinner with no meat in it at all. So,
for the diversity and enjoyment reasons, naturally, you do that. However, the question is, do you have any data, have you come across any data in your experience that would support the health consequences of either doing eating meat every day, red meat every day, or not?
Yeah, there are studies which suggest that high intakes of red meat might not be good for cancer of the large bowel. But there's a big but with this. It's not so much the red meat as the doneness of the red meat. It's whether you mutilate your red meat on your barbecue and burn it to bits, because the things which are carcinogenic or potentially carcinogenic are not the proteins in the meat, but the way in which the proteins react with the sugars to cause the browning and the darkening browning and so forth. So the more sort of cooked it is, the more likely it is to be a problem. But I'm not convinced that the data is terribly strong. But the World Cancer Research Fund would say that we should reduce our intake of red meat, and especially well-cooked red meat.
Hi. I was just wondering, when you said that basically your genetics determine whether you're going to be obese or not, whether you're in an obesogenic environment or not, does that mean that you kind of think people can't make their own choice? I mean, like, they can make choices, but is it kind of predetermined by your genes and your environment?
I mean, in a sense, the environment will play a role, but the genes will tell you which one of us is going to be the weakest and give in to the next serving of pudding. The big advantage of going down this road, even though we can't change our genes, is that if we can understand what combinations of genes are responsible for helping people to get obese, then we have a chance of going to people early in life and saying, look, you have a higher than average chance of getting obese for the following reasons. In your case, it might be that you're going to be tempted to eat a lot of food. Others have different metabolism, but we'll begin to know why. And therefore, we'll begin to target solutions to these people earlier on. And that's the big advantage. Of course, it would be great if we got rid of the obesogenic environment, but it's never going to happen. So it's much better to accept that this is the way we live, good or bad, and to try and understand how, by a knowledge of persons' genomic makeup, that we can help them to deal with it. And there is data coming out, for example, that is suggesting that certain genetic makeups mean that the type of diet you use to lose weight is best determined by your genes. So we'll know what's best for you when you go to lose weight as well.
Right, if you can go back to the carrot example, what would be exactly and precisely the difference between an organic carrot and non-organic carrot? Like, I read and we hear about a lot of stuff about the difference, but what is exactly the difference?
About 50 pence a kilo. And after that, nothing. Nothing. That's the thing. I mean, it is just not possible to make the carrot anything other than the carrot. And this is the mistake that the organic movement have made, is to try and embellish their approach to agriculture with advantages that don't really apply. You don't, for example, hear vegetarians, they just get on with their lives, vegetarians, and they buy vegetarian meals and they live a vegetarian life and they don't moan and groan about it. You will see the organic movement not doing that, for a very simple reason, that absolutely everyone in the organic movement has a vested interest in it. They're either farmers or they own shops or they have processing units or what have you. They're in the value of organic, the business of organic food, and they want to pump up its value and its worthiness and so forth. So they will make out that it's better for the environment, better for this, better for that. But it's just not true. And the carrot is simply the same carrot. Because if you take the transmission of zinc from soil into a plant, there's no border police in the carrot saying, sorry, you're organic zinc and you're inorganic zinc. It's a zinc ion. That's it. Like, there's no difference. So it's impossible to say there's a difference between the two.
So build on his question here, it's basically one big marketing scheme that is misleading us and where we pay extra for it globally.
Well, the way I view this is that people who buy organic food know that they're buying into a form of agriculture in which it is laid down exactly what can be done. So this issue of the horse meat, maybe, if you had organic burgers, I don't think that could happen because they have a far greater stringency about it. So what you're buying into is a certainty about an agricultural production system. Now, if that's all that you do, that's terrific. What I find is that people who purchase organic food make people who don't purchase organic food feel guilty about what they're doing to their kids by not giving them organic food. That's when I step in. Now, if they want to buy organic food and say, look, I just like the idea of organic agriculture, I trust organic food, I trust their production system, terrific. I have no problems with that whatsoever. But where I do have a problem is when they start to make other people feel, you know, would you dream of giving, you know, conventionally farmed carrots to your baby, kind of thing.
There is a lot of pressure on moms to breastfeed now, and I was wondering if if it's true or if it's a myth that the advantages of breastfeeding are as many as they are advertised. When you go to a baby center, everywhere they are everywhere. So
Yeah, it's probably the most dangerous topic in the world to comment on. But without doubt, breastfeeding has enormous advantages, not just biological advantages, but psychological advantages as well. In the developing world, breastfeeding is far more important. I mean, really, it really has to be the case in the developing world that children are breastfed exclusively for 6 months. Has to be. Now, here in this part of the world, the reality is that a fraction of women cannot produce enough. And if you look at dairy cows, and you look at the output of dairy cows, it is distributed exactly like any other parameter in life. It's bell-shaped. Some are good, some are bad. They breed up the ones that are good and rid of the ones that are bad. So it's exactly the same in women. Someone will be excellent lactators, some will not be. There's nothing you can do about it. And the problem is that to make women who can't breastfeed feel guilty about using a bottle is shocking in my view. Now there's another interesting area about if women have the right to choose or to terminate a pregnancy, say in many countries, surely they have a right to choose not to breastfeed. Now the counter argument to that is the child is born and the child is entitled to breastfeed and therefore the mother should breastfeed. But there's a deep philosophical issues there, but basically speaking, breast is best for sure. In the developing countries, it's absolutely essential. In our part of the world where people are busy working and so forth, sometimes lactation is not so easy, in which case formula feed is perfectly acceptable and they should not be made feel guilty about it.
I just want to ask, what are your views on diets? Because now people kind of feel that they go on diet, they lose weight in 2 months, and then they want to eat even more and gain all of it back plus extra. It's the first. And second, if losing weight can be linked with psychological kind of, so you want to lose weight and you kind of imagining yourself losing it and you kind of have a bigger progress than you would go on any diet.
I'm not too sure about the second part of the question, but the first part, you're absolutely right. I mean, look at me. I've been on more diets than I can care to talk about. Basically, there's a wonderful statement from the American Medical Association's Council on Scientific Affairs, where they talk about the 5-year cure rate for diseases. Now, basically, the 5-year cure rate for the worst cancer is better than the 5-year cure rate for obesity. If you take 100 people and cure them of cancer, come back in 5 years and ask how many are free. So if 20 are still free, your 5-year cure rate is 20%. Obesity will be worse than that. It is a disastrously difficult thing to get rid of it easily. It's very difficult. To keep it off is really, really hard. And it requires lifelong dedication. And take your foot off the tiller for 1 minute and whoop, you'll be back. So the advice is never to gain weight. My advice then to people who are going to lose weight is don't lose weight until you really, really, really want to and know why you want to lose weight. So for example, if your blood pressure is fine, if your blood glucose is normal, if all of the other signs are perfectly, ask yourself, well, what am I doing it for? I would strongly recommend that nobody starts a diet until they have built a little bit of physical activity into their lives, because that is the most important thing, is to get some level of physical activity, walking for 40 minutes a day. Once you get that in, only go on a diet if you really have to. But be prepared for very slow weight loss, and you need to be at it all the time, watching it all the time, because it'll come back, fortunately.
You mentioned genetically modified seeds and Roundup resistant seeds, and my understanding that Monsanto produce a lot of these seeds and they also sell Roundup, so they've invested money both ways. Do you think there are health risks to eating food? The majority of the corn and wheat in the US is genetically modified to be resistant to Roundup. Health risks in eating that corn as a result of poison being sprayed on?
I can't see any. There's no evidence that in the United States or in South America where genetically modified foods have either been fed to animals or fed directly to people, that there's been any adverse effect whatsoever. And I'd go back to the point that you have been eating atomically mutated plants all your life. So they are a blunderbuss compared to the precision and accuracy of genetically engineered foods. And it's not always Monsanto that it's not always big corporations. Many of the breakthroughs have come from, for example, the University of Leeds have developed a potato, and there's a protein on the leaf of the potato which weevils don't like. They get sick. And that goes back to the point that plants have to protect themselves. But the weevil doesn't like it. Now, if you get the plant tuber, the potato, there's none of that protein isn't present. So the weevil has a field day on it. So what they did at Leeds University was they took the protein from the leaf, they genetically engineered it into the potato. Now the weevil won't go near the potato. Now they can only take that far. They can't take it beyond that. They need the Monsantos or someone else with the resources to make it happen. And it's the same with golden rice, where they've introduced the vitamin A type beta carotene into these rice, which will now go on sale next year in South Asia. But for example, the Greenpeace movement completely wrecked the University of Leeds plants. They had to start doing their work outside of, in safer places. BASF, Plant Science, one of the biggest GM forces in the world, have moved out of Europe. And so a lot of the technology will come from labs, and they'll have to be taken on by big corporations because no one else can do it. I can't see any dangers whatsoever in genetically modified foods. I'll give you, on sale in this country, every cheese that's on sale in this country, in the old days, they used to take rennet from a calf's stomach and use it to help curdle the milk. And because of the price of beef, calves weren't being killed at young, they were bringing them on. So they invented, they got a yeast. They genetically engineered the yeast to produce a protein that did exactly what the calf's stomach did. So for the last 30 years, every piece of cheese that you've ever eaten in your life has been curdled using genetically modified proteins. And you're not mooing, are you? So, it's very emotional. It's been made very emotional. And it's quite interesting that Greenpeace are rowing back on this. Greenpeace have begun to say that it's not always bad. You will find people saying that they rubbish genetically modified food on the grounds that it's not going to feed the world. Nobody said it was going to feed the world. It might contribute to it, but it's not going to feed the world. It might help. So I don't see any dangers in it at all.
Okay, we're running out of time, so I've got one person with a question here and maybe just one more after that.
Thanks a lot for coming. You gave the example of a tomato from Ireland versus the tomato from New Zealand. Do you have any studies that actually show the carbon footprint? Because I always find it hard to argue when people say, yeah, I only want local food. And then I say, oh, well, at what price does that local food come? And then it's always the exact argument that you made, yeah, well, it's shipped from the other side of the world. But it's like without the study behind it, it's kind of hard to say how little of an effect it actually has on the carbon footprint.
Yeah, there are plenty of studies available in the scientific literature on it. Apples from New Zealand was one case study, but there have been models have been done of the food chain and where the carbon is. Basically speaking, local food is fine for restaurateurs. I was talking at that talk in Cork yesterday. This lady was saying that she lives out in the country. And she gets all her herbs from the side of the road and all that. And I thought, what a privileged woman you are, I mean, I can't see everyone walking around the side here looking for herbs. And, it's a selfish thing, lucky thing, good for them. But don't start standing up there like a saint and telling us that you're holy and we're sinners, you know. I've great faith in the food chain. It goes wrong from time to time. I've great faith in it. And I think that eating local is a nice concept, but it's not going to work. Our exports would collapse in this country. 9% of our GDP, 9% of our exports come from agri-food. So if we couldn't export, we'd be dead in the water. Kenyan farmers couldn't sell their flowers in Holland. They'd be dead. Trade is what made the world go round since the discovery of ice routes. Probably haven't answered your question, but buy the book.
Hi. Yeah, just interesting to hear your thoughts around nutrition during pregnancy and how that primes people for later in life. I was lucky enough to get a free copy of your book. I'm just reading the back, and I couldn't wait to hear that bit.
Well, it is interesting. Basically speaking, you inherit your genes from your mother and your father, and you sit. They sit into the embryo, and they nurse along, and the genes are. Well, let me go back a little bit. In my right earlobe, I have my entire genome, and in my liver, I have my entire genome, but my liver doesn't hear anything. And my earlobe doesn't make anything. And the reason why they differ is the things that the liver does are switched off in the earlobe, and the things that the earlobe does are switched off in the liver. So genes are switched up or switched down or switched off. Now in pregnancy, the mother's environment has a big say in how the dimmer switch is operated, whether it goes up or down. And when the child is born then, if they're born into an environment that matches the plan that the mother had for them, they're fine. If they don't, by the time they get to 50 or 60, they will begin to develop chronic disease at a great rate. So there's fabulous stuff which goes back to, say, the Dutch famine during the Second World War, where people entered that famine pregnant, got pregnant during it, or had a baby during it. So different trimesters of pregnancy. And looking at those people, those survivors, 40, 50 years later, you can see the point in pregnancy where the damage is done, where their genes were altered in such a way to expect a very, very low level of food in Holland at the time. And then they grow up into this obesogenic environment, and it's a mismatch. They're a very hot topic. And I'll go further than that to say that in the period immediately after birth, the example I always take is let's say, my grandson. He's going to learn English. He's going to learn to eat with a knife and fork. He's going to learn all the cultural things we do. A child born yesterday in Taiwan is going to do something completely different. So the humans are born with a non-hardwired brain. Our brain is plastic. A foal is born with a hardwired brain. It gets up on its four legs and it trots off with its mammy. Has nothing to learn. You can teach it a few tricks, but humans have to have that plastic brain in order to absorb all the culture they're born into. And so there's what's referred to now, particularly in the developing world, is the first 1,000 days. That covers conception right through to 2 years of age. And if you get nutrition wrong there, you have trouble in later life. And it's irreversible. So for example, if you don't get proper brain development in that 2-year period, because the brain is still growing, it will be irreversible. You'll have a low IQ all your life. If you don't get enough food to build the body in those 2 years, you will set your height much lower than your genetic potential. So you'll be physically stunted and you won't have the physical capacity to do work. So there's a recognition now, a huge recognition that is important. And the United Nations have this program called Scaling Up Nutrition. And they focus on this first 1,000 days. Hillary Clinton is one of the big champions of this, and our own minister, the minister here as well. It's a really absorbing area. It's fascinating.
Okay, I'm afraid that's all we have time for. For those of you who were lucky enough to get books, Mike will be happy to sign them for you after. For those of you who didn't, you can buy them on Amazon, UCD Press, where else? I don't know. Book Depository, I think, as well. Thank you. It's great to see such a wonderful turnout for one of the authors at. And thank you, Dad, for a great talk. Thanks very much.